Start recording. Okay. Hi. Welcome, everyone. This is the Intro to Unity coding event, and I'll just pull up my slides here. Can you guys see the slides?
Yes.
Awesome. Okay, so I have essentially just created a new Unity project here, and we're going to be going over stuff. It's important. One of those things is optimization. We're going to be going over components and caching, physics, but it won't be terrible like physics classes in university are. It's going to be pretty simple physics. That's fun. We're going to go over killing bad guys. We're going to go over some funky, fresh design patterns, and we're going to go over a little bit of concurrency, which is surprisingly hard to do in Unity, but also easy sometimes depending on how you do it. It's weird. So we have a project reference at this link, which will be pasted in chat. Why not right now? Can I copy this? I can. Copy link address. And I'll just drop this in chat quickly for anyone who wants it. And there is the reference version of the project, and then there's the live version of the project from last time, and then the version from this time is going to be here eventually after we do the thing. So the first thing we want to talk about is the Unity update lifecycle, which is a pretty important thing to understand if you're doing stuff with Unity, naturally. And I'm going to pop out of here and go over here. So this is the update lifecycle. It looks kind of complicated, but honestly, you're going to use like 3 of these functions probably. Right, Jaden? I mean, how many of these have you used? Not a lot.
In my lifetime, probably like 5.
Yeah, literally. Like, you're not going to use all of these. You don't really need to know all of these. And the link for this is also about to be dropped in chat. So I would save that, and then you can reference it, because it is quite handy when you do need it. But basically, this is the order functions execute. Like, if I go in Unity here, and I create a script, and we're just going to create a C# script. We're going to call it test for now. But if I go in here, if it'll open, there we go. So as you can see, we have like the start function. I don't care about the release notes. We have the start function, and we have the update function. There's more than just those two. There's also like awake, on enable, reset, start, which we already know about, fixed update, and blah, 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 all of this stuff. And these are really important because usually like you'll want to do, how it says here, initialization. So in your awake and on enable functions, you want to do like, you want to initialize your variables type deal. And then, for example, like if you're doing physics stuff, you really want to do it in fixed update instead of regular update, because things get weird otherwise. I'll explain the difference between regular and fixed update later. And stuff like that. Like, there are certain times when you'll need things to happen in a certain order, and being able to know what order all of these functions go in is really useful for that. I don't know, does that make sense, Jaden? Would you want to add anything to that?
No, seems reasonable. One thing I would note is that like awake happens before start. So one thing I find useful is like if you have something like that depends on another class already being initialized, it can be helpful. Like in the thing you already need to be initialized, do that in awake, and then like when you need to depend on something else, do that in start, so that you know for a fact that the other thing has already been initialized when you're using your stuff in start. If that makes sense.
Yeah. Yeah. Also, yeah, if anyone has any questions, just ask them in chat. I'm pretty sure Jaden's keeping an eye on that, so hopefully we will get to those quickly. Anyway, back to the slides. Oh yeah, so fixed update versus update. This is the later part where I go over that. So essentially the difference is fixed update happens in the physics update, and it will happen 60 times per second no matter what. Update happens once per frame. So like if you're on a really powerful PC and you're running at like 300 FPS, update is going to get called 300 times per second. Whereas fixed update is always called 60 times per second, which is why it's fixed. You can change how often fixed update is called in your project settings, but for all intents and purposes, like for this presentation, fixed update is called 60 times per second all the time. So another thing we want to go over is sort of on enable, on disable, and on destroy. Those are really handy functions for basically on enable is like when an object, or sorry, when a script gets enabled, which is like in Unity, we can say like this.enabled equals false, right? And that'll stop update functions from running on the script, right? And so that's pretty handy if you want to stop a script from doing something. But we also have, if you look here, on enable, and where is on disable called? On disable. It's called all the way over here. So basically, if you want to do something when your script is enabled, that goes in on enable. If you want to do something when the script is disabled, you do that in on disable. You won't. Oh, someone's knocking. I'll be back. All right, I'm back. So yeah, like honestly, just thinking about it right off the bat, on enable and on disable, you might not see why they're useful, but it's another thing. Like as you go, you'll find use for them. It's just good to know about them. And then on destroy is the last one. That gets called right before a game object is destroyed, and this is really handy. Like if you want something to happen when an enemy dies or something like that, right? Like you're going to destroy the enemy when they die, so you might want to put extra logic in on destroy or something along those lines. Yeah, that's it for that though. Jaden, do you have anything to add to that one?
Nope, sounds good.
Okay. So yeah, next thing we're doing is we're going to work on a character controller. So this is where we're going to get a bit into the meat and potatoes of actually coding here. I'm going to assume that you have sort of a base knowledge of C# or at least some other programming language. Like, I'm not going to go over what a variable is and like basic syntax. If you've never done C# but you've done Java, C# is basically the same in terms of syntax, so you'll probably be fine. Anyway, I'm going to delete this. I pressed the wrong button. I'm going to delete this test class, and I will create a new character controller class once Unity stops loading. Okay. So we're going to create a new C# script. We're going to call it character controller. And the other thing we'll probably want to do, oh yeah, sorry, I'll have to rename this because character controller is the name of a Unity component, which we're actually not going to be using, funnily enough. Okay, attempt number 2. Player controller. That name should be okay. All right, and now we're going to create, before we actually code the player controller, we're going to create a basic level for the player to exist on. So we're just going to create a square, and we're going to call it floor. And then we're just going to move it down to, I don't know, like -5. Yeah, that seems good. And then scale it to 10, 15. And then we'll add a box collider. So this is just going to act as our floor. It'll be something for the player to stand on. That's what floors are. So that's that. And then we'll create our actual player, which I believe when Jaden did this, there was art involved. But if I'm being honest, I did not prepare that hard. So we're going to do a capsule called player. And then on this guy, we're going to add a rigid body 2D and a capsule collider 2D. So what this rigid body 2D does is it gives the player physics. That's all that is. And the capsule collider gives the player collision. So we can respond to physics and run into things. So if I run this, as it is now, basically all that'll happen is the player will fall. Boom. Perfect. It's working. So now we're going to, this is very important, we're going to take the player controller script and we're going to add it to the player. Because if we forget to do that, none of this will work. All right. So let's make the character controller. Let me just reference. Yeah, okay. So we're first just going to start with something really simple where we move around the player. So we're going to say in void fixed update, because we're using physics to do this. And remember that you should always do physics in fixed update. We're just going to say float input equals input.get axis horizontal. So we very briefly went over this in the intro to Unity, like the first one where Jaden was presenting. Essentially what this does is the horizontal axis is the A and D or the left and right arrow keys on your keyboard. So what get axis does is it returns like -1 if you're holding down A, +1 if you're holding down D, and then it returns 0 if you're holding down neither or both, if that makes sense. And also for a controller, since controllers you can like move the stick a little bit, it'll return numbers that, like 0.5 or whatever if you're only moving the stick a little bit. And this is just like Unity's cross-platform input thing. So this works with controllers and keyboards and all that stuff. And let's close that because we don't need it anymore. Okay. And then the next thing we're going to do is pretty simple. We're going to get component rigid body 2D. And we're going to say dot velocity equals new vector2. And then for the X, we're going to say input. And for the Y, we're going to say 0. Because why not? So essentially what I'm doing here is I'm getting the rigid body component, which if you remember is this guy on the player that gives him physics, right? That's our rigid body. And we're setting its velocity to a new vector. If you don't know what a vector is, basically it's like an X value and a Y value. And it represents, it can be like a position, or in this case, a velocity. And what we're doing is we're saying along the X-axis, just have our input value, which is going to be -1 or 1 or 0. And for our Y-axis, just have 0. So let's run this and see what it actually does. Okay, so right off the bat, we can see the player is like falling really slowly. It's like in slow motion or low gravity or something, and it's crazy weird. And then if we use A and D, we're kind of just like, we're moving left and right, but the player's falling and rolling, and it's all weird. Like, we've fallen over now. That's not at all what we want. So how do we fix that? Well, first, let's fix the really slow falling. So if you notice here, we're setting the velocity to 0 on the Y-axis, and logically you would think that the player will just not move at all vertically. But because of how Unity works, they just end up falling really, really slowly. And that's kind of to do with the update loop we showed earlier. And I'm not going to get into why exactly unless someone really wants to know. But yeah, basically, because we're setting this to 0, we don't fall properly. So what we're going to do is we're going to make this a little more complicated, but it'll be pretty easy to read still. We're going to say vector2v equals get component rigid body 2D dot velocity. And then we're going to say rigid body dot velocity equals new input blah 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 v dot y. So now what we're doing is pretty much the same thing, except we're setting the y velocity of the rigid body to whatever it already is. So we're just not changing it. And now, if we run this, we should fall normally. Fingers crossed, because if not, then I did this really wrong. But we should be good. Yeah, so now we fall normally. But if we move, we still kind of tip back and forth and then drag along the floor. So that's still completely broken. but at the very least, we fall properly. So now, how do we fix the player tipping over? That's actually a little simpler. We're just going to hop over constraints, and we're going to say freeze rotation. And essentially what this means is don't allow this rigid body to rotate at all. Because what was happening before is like it was doing friction calculations and saying it should fall over. Now we're saying don't do that. Just don't rotate. And that completely fixes our problem. As you can see, we're all good. We are moving as we should. So now lastly, I mean, our character is moving. This like works, right? We kind of have a player controller, but we're pretty slow, you know? This is a very slow character controller. So what we'll do, just for fun and for ease of use, we're going to say public float move speed, and we're going to set it to like, I don't know, 3. And then here we're going to say input times move speed. So what this does is this creates an inspector variable. So if we go over here and look at this, in this player controller, we should now have, when it loads, a variable called move speed, and we can change this to whatever we want, like a bajillion or 0 or 3, which is what we had before. And that just makes it really easy to change this sort of on the fly. And what this part does is we're saying input is -1 to 1. We're basically using that as our direction, and we're multiplying it by how fast we want to go. So then if we run that, we should move 3 times as fast because our move speed is set to 3. And that feels a bit better already. Now the cool thing about an inspector variable is, let's say this doesn't feel quite right. Like I want it to be a bit faster. I don't have to go into the script and change it. I can literally just go right here. I can change this to 5. Boom. Now that's even faster. Let's say I want faster. Let's do 500. Really break things. And see, I just zoomed out of there. Because we're going a speed of 500 now. That's really fast. If I restart this, it goes back to 3. So what you do is you test around, find an amount that feels right. Let's go with 4. I think 4 feels pretty good. And then we'll remember that, and we'll set it to 4, and then we'll save that. And now it's saved in, and the player speed will always be 4. All right. Yeah, so the next thing is now we have like a pretty decent player controller, right? We can move around. We can change our move speed whenever we want. We don't fall over. Like this is pretty good. It's pretty good. But it can be better. So if you've ever had Abdullah in your as a programming professor, you'll know that when you see repeated code, we hate this. So if you look here, we're calling get component twice. We don't need to do that. That's silly. That's inefficient. So we're going to go right here. We're going to say rigid body 2D. We'll just call it like rig for short. We're going to set that to get component rigid body 2D. And then we'll just say rig. So what this is doing is every time you call get component, it takes time to do that because Unity has to like go through the list of all the components, figure out which one is the rigid body, and return that. So what we do is instead of calling it twice, we call it once, store a reference to it, and then we just use that reference, which makes things a little easier. And you might not think, like, what's the big deal, you know? It takes a little longer. But if you have a fully sized game with hundreds of, like, get component calls all the time, the performance impact is really going to show. Things are going to run slowly, your game's going to be jittery, no one's going to want to play it, right? And that's the last thing you want. You want people to play your game. So by doing this, we've effectively, honestly, like we've doubled the speed of this function almost because we've reduced 2 get component calls to just 1. But now you might be thinking, can't we do even better? I mean, if we can just store a reference to this, why would we get it every fixed update? Because fixed update gets called once per frame. But our rigid body is the same rigid body all the time, so we don't need to get it every frame. So what we're going to do, we're going to go up here, private rigid body 2D rig, and we're going to get rid of this one. But this will just be null to start out. And we don't want it to be null, obviously. So at awake, which if you recall is one of the first functions that gets called when a script starts. We're going to say rig equals get component rigid body 2D. Now this, we've added like 4 lines of code, and it's way, way, way faster. Because instead of calling get component every single frame, we call it once. And that's it, right? That's so much faster. And if we go over here and we run it, it's going to work exactly the same as before. Because functionally, nothing has really changed. It just does it faster. Oh, okay, cool. It's just not going to run. Let's try this again. There we go. And as you can see, it works exactly the same as before. It's just faster now. Not noticeably, but it is technically faster. All right. So what's the next thing? We did caching components. So now, all right, we're doing grounded checks. So one thing you might be noticing is our player controller can't jump. That's no fun. Jumping is fun. So let's add that. Let's add jumping. What's an easy way to do that? Well, we'll say update here. We'll say if input.get button down jump rig.add force vector2.up times jump force. And we'll create a variable up here called jump force. So what this does is update is called once per frame, and get button down will return true if you just pressed a button, right? Which is the button you put in here. So we're looking for the jump button. We're saying, did we just press the jump button? And if we did, we're going to add a force to the rigid body, which is the up force, so in the up direction. Oh, and sorry for the weird pauses. I'm just drinking water. I'm thirsty. Anyway, so we're just checking if we press the jump button, we're going to add a force. Now, you might want to know why we don't do this in fixed update. And that's because since fixed update is only called 60 times per second, if you press the button like in between the 2 fixed updates, it won't register, right? You'll notice it. I can't really demonstrate it over video, but you'll notice that sometimes when you press the jump button, you won't actually jump. And that's because it's being called in fixed update. So we have to call it in regular update to make sure that we like get all of the button pushes. And that's just like a weird quirk of Unity, but it's you get used to it. So now, and by default in Unity, the jump button is space. So if we go in here and we press space, we should jump. Okay, we're not jumping. I've done something wrong. Let's see what I did wrong. The jump force might just be too low. So we're going to say... Is that how that works? Okay, yeah. So this last bit I added, I actually did this wrong the first time. So doing a regular add force is like for adding force over time, which doesn't work for jumping because we just want to add like one upwards force and be done with it. So what I've done here is I've said force mode 2D.impulse, and essentially that makes it an impulse force. Like if you kick a ball, that's an impulse force on the ball because it's like a really short sort of one-time force. And that should make it that the player actually jumps. Yeah, and as you can see, now we're jumping. We're jumping pretty high. And actually, if we press the jump key again, we can just keep jumping up forever. Like, we can absolutely zoom out of here. If you look at the Y position, I'm just going way up into the sky right now. Because we never checked to see if the player was on the ground. We just said if we press space, then jump. So I'm sure you can see why that would be a problem. We only really want to jump if we're on the ground. So let's fix that. So what we're going to do here is we're going to use Unity's physics system to check if we're on the ground. And this is where things are going to get a little interesting, but it should be fine. So what we're going to use is something called an overlap sphere, I believe. And what that does is it creates an imaginary sphere sort of wherever you want. In this case, we'll be doing it like at the player's feet. And what it does is it tells you what is in that imaginary sphere, or actually in this case circle. It would be an overlap circle because we're doing it in 2D. But yeah, it tells you what's in that circle. And basically what we're going to do is we're going to do an overlap circle, and then we're going to say, okay, is the ground inside of the circle? And if it is, then, you know, we can jump because we must be on the ground, right? Because the circle is at the player's feet. And then if there is no ground, then we say we can't jump because there's no ground. So the way this function works is we basically say collider 2D. Oh, and also actually, this should be done in the update thing. So we'll just go here and say movement and grounded check. So we're going to say collider 2D equals physics 2D dot overlap circle. All right, so if we look at this here, our player's position is right in the center. And that's not really where his feet is. So we need some offset that'll go to his feet. So what we're going to do is we're going to create an empty game object. We're just going to call it feet. And we're going to move it right down there. And now it's right where his feet would be, which is what we want. So we're going to go up here again, and we're just going to say public transform feet. And if you don't know, a transform is just a reference to like a game object's position and rotation and all that. So what we want to do is we want to make the overlap circle at feet.position. And then after we do that, we want to specify the radius. So we're going to do a pretty small radius, like 0.2 should be fine. Because we don't, like, we want to be really close to the ground to count as on the ground. Because that's what makes sense. So we're just going to do a pretty small radius of 0.2. We might make it smaller later as well, but we'll see. And for now, we're just going to do that. And then I believe this should return null if there's nothing in the circle. But it doesn't actually say in the Unity docs. So what we're going to do is we're going to debug the collider. And then that's all we're going to do for now. So just to recap, what's happening is we're doing the overlap circle and we're debugging what's in the circle. We're not actually determining whether or not the player can jump. We're not there yet. So we'll still be able to jump in the sky and stuff. We're just debugging what's in the circle. So once this game is started, I'll open this up. Oh, look at that. We forgot to assign the feet. So if we go here, we have this little thing for feet. We're just going to drag feet in there and drop it on that variable. And now the player has feet. All right. So as you can see, we're logging what the circle is touching all the time. And it seems to just be touching the player all the time. Which makes sense, right? Because if we're doing a circle sort of, you know, right here, of course the player is always going to be inside that. The circle is right on the player. So how do we fix that? Well, we use this thing called a layer mask. They're actually really easy to use. We're just going to say public layer mask ground mask. And if we go into the inspector here, we're going to have this little thing once it loads. There we go. where we have a ground mask and it's set to nothing right now. We can set it to everything, or we can select specific things. So for this to really work, we need to grab the player, and we need to create a new layer for it. We're just going to call this layer player. It's the player layer. And then we're going to set the player to that layer. I'm rhyming. All right, and then we're going to set the ground mask to everything except for the player. And now what will happen is this will select every layer except the player layer. So once we pass it into here, what did I call it? Did I call it? Yeah, ground mask. Once I pass it into here, basically what's going to happen is this is going to search for every object except for objects on the player layer. So it's only going to detect things that are not the player, if that makes sense. I feel like I'm making this a little convoluted. But let's just try it and see what happens. All right, so now if we look at the logs, we're detecting the floor when we're standing on it, and then when we jump, we're returning null because we're not on the ground at all. Which, that's good. That's exactly what we want. So what we've done with this layer mask is we've told it to completely ignore the player and pretend it doesn't exist, basically, which is what's happening. So that's kind of perfect. That's exactly what we want it to do. But now how do we actually check like whether or not, we can jump? That's actually one of the more simpler parts. We're just going to say private bool can jump. I'm going to set it to false by default. And then here, we're going to say can jump equals collider doesn't equal null. So what this is saying is, let's look at this part first. If the collider is not null, this returns true. And when the collider is not null, that means we're standing on the ground. So basically, this determines whether or not we're standing on the ground. And we're setting can jump to true if we're on the ground, or false if we're not. So now in here, we're going to say if we press a jump button and we can jump, then add the force. So now if we try this again, I should be able to jump and then just like keep pressing my spacebar, but I won't jump any higher, which is exactly what's happening. I don't know if you can hear my spacebar. I feel like you probably can, but now we only jump when we touch the ground, which is perfect. That's exactly what we want. All right, so yeah, that's the character controller. All right, now we get to do enemies. This one's going to be fun. So let's create an enemy first. I'm going to be really creative, and I'm going to create a... Jaden, what do you think? What shape should I use?
I feel like they should be circles.
Circles?
No, squares. No, I feel like
Squares?
squares are even more evil. Yeah,
All
squares
right.
are evil.
So we're going to call this guy enemy. And we're just going to put him... We'll put him like above the player for now. Put him at 5. And we're going to make him red because he's a bad guy. Let's get fancy with it. Make it like a... Oh, I actually hate that color. Never mind. Okay, we're just going to do red. So currently, this is going to do absolutely nothing. It just sits there. We can't quite reach it. But yeah, it does nothing. So let's make it do stuff. I think the first thing we're going to do is add a box collider, 2D, that is, so that it interacts with physics. And then we're going to add a rigid body 2D. And that'll be able to fall on the ground. So let's see how that goes for us. Okay, cool. We have a little box here. And since our player is like totally integrated with physics, we can push him around and stuff, which is pretty fun on its own, but we're gonna move on to greater things. Now we have to make an enemy script. So let's make another script. We're gonna call this one enemy controller, and we're gonna open it. And before we start, so we don't forget, excuse me, Unity, we're gonna take the enemy controller script and put it on the enemy so we don't forget, because if you forget to put the script on, nothing will work. So what I want this enemy to do is I want him to sort of figure out where the player is and then follow the player. And that's really cool and all, but how do I actually, like, get the player's position? I mean, I could have, like, a variable that references the player, but when we go into, like, spawning enemies on the fly, which we'll do later, that doesn't really work because we can't, like, set the player beforehand. It doesn't work like that. So, I mean, what do we do? Well, there's this really handy thing in Unity called the tag system. And the way the tag system works is if we select, for example, the player, and we go up here, it says tag untagged. Well, we can select from this amazing list of tags. We can even add our own tags. And it tags that object with something. And then we can find a game object by its tag. So we're going to take the player and we're going to give it the player tag, because that just sort of makes sense. So we give it the player tag, and now we can get that object by its tag, which is really, really handy. So we'll say void awake, and we'll say game object player equals game object dot find. What's it? I forget the exact wording. I don't have IntelliSense in it. It bugs me. Yeah, find game object with tag. So find game object with tag player. And then we're going to debug.log player. So let's see what that does. If we're right about how the tag system works, then this should just log the player, right? That makes sense. So let's try it. And wouldn't you know, it works perfectly. Player Unity engine.game object. That's this guy right here. That's what we want. So that's good. So now we're going to store the player in a variable here. Now, we could get the player every frame, sort of like what we were doing with get component on a player controller. But just like get component, this is really slow because it has to go through every single game object and find the one that's tagged with player, right? We don't want to do that every frame, so we're going to do it once in a wake, and we're just going to store it. So we're just going to set player to whatever we find from there. All right. Now the next thing we got to do is we have to move the actual like enemy character. So we're going to create a variable for a rigid body because we want to store that too.
Now, we've got a question in the chat here from Stu, which I figure you might as well answer for our stream as well. Can you have multiple tags on the same object?
You cannot. Which honestly I think is a huge limitation of Unity. Like, it would be really cool if you could, but you can't. There are other things you can do. Some things that I've done is I've created components. And they don't actually like have any function. They just maybe store a couple of variables. But what you can do is you can say, like, for example, if we say transform t equals, was it find object by type? Like find object with type, and let's say player controller. This works basically like find game object with tag, but it looks for a transform with this component. So right now we're looking for like a transform with the player controller component. And if we log it, we should just get our player. Nope, I spelled it wrong. What is it?
It's object.find object of type.
Find object of type. There we go. Okay. Yeah, and then, oh yeah, sorry, it returns the type you're looking for. So yeah, this will find a game object with this component and then return that component. So what this will do is it'll be exactly like the tag thing where it'll find the player. If it'll load, I would like to demonstrate this. yeah, so it found the player again, just like before. But what you can do is, like, you can have as many components as you want. So essentially you could use this as a tag system and have more than one tag. But yeah, does that answer your question? I do need to actually check the chat. Awesome. All right. So yeah, we're gonna back to what we were doing. We're storing the rigid body now, and we're gonna actually move the enemy around. So we're gonna go into fixed update again because we're doing physics stuff. We're gonna move the enemy with physics like we did the player. And so what I want is for the enemy to just move towards the player. But how do I actually do that? Like, I have the player, right? I can get his position and stuff, but how do I get a direction to it? If you know, I don't even remember what like level of math it is, but where you do vectors and stuff and find directions, you'll kind of know how to do this. But the long story short is you could say like vector to direction equals, and then it's where you're going, so from minus where you are. So that's actually, no, it's, yeah, where you're going minus where you are. That's how you get a direction, and then you normalize it. So we're going to say where we're going is player.position minus where we are is transform.position. So transform is a special thing. I think we went over it in the intro to Unity. This just references this script's transform component. So we can easily change position and stuff like that. And then we're going to normalize this. So if I got this backwards, basically our enemy's just going to move away from the player, which isn't too bad. But we'll do that. So we have a direction to the player now. And we're going to say rig.velocity equals direction. We're going to see what that does. So if we hop back into Unity here. Oh, I did something wrong. Oh, yeah. So the player we're storing is a game object, so we have to say player.transform.position. And that's because like we're storing a game object. We need the transform of that game object. So we have to add in the little dot transform there. And if we run that, in theory, yeah, so this guy's moving towards us. He's moving very slowly. And we have the same problem as before where, like, he doesn't actually fall properly. He's very floaty. But he is sort of moving towards us. So how do we fix the floatiness? Well, same way as last time. We're going to say velocity is a new vector to direction.x and rig.velocity.y. And that way, he'll fall properly. So if we do this, boom, there he goes. He's moving towards us. Once again, very slowly. He's like a little snail. And we can push him around, stuff like that. So, again, like last time, we can just create a public float move speed. And I'm going to set it to like 1.5. I don't want my enemies to, actually, I'll set it to 2. So my enemies will be slower than the player, but they won't be super slow. And I'll just multiply this by move speed again. This is exactly like last time in the player script. It's the same thing. And then once this loads, if we go here, we have the speed variable just like last time. And now our enemy should move a bit faster. Yeah. And he's coming towards us. So that's exactly what we want. And then if we don't do anything, he should be able to just push us off the edge. Which is kind of what I'm going for. I want my game to be kind of like a stay on the platform thing. So there's that. Yeah, so that's this bit here, using tags to locate the player and enemy movement. Now we're going to use physics to curb stomp some baddies. That sounds like a lot of fun, I'm going to be honest. So how does that work? Well, what we're going to do is, you know how in Mario you can jump on a bad guy and they die? We're going to do the same thing here. So essentially there's 2 parts to this. We have to, 1, detect where the player is, like whether or not they're on top of us. And 2, we have to, if the player is on top of us, we have to die. So, I mean, how do we do that? Well, let's split this up again. Getting curb stomped. All right. So how do we actually detect whether or not the player's on top of us? There's a lot of ways we could do this. And the way we're going to do it for now is with Raycasts. So one thing we could do, I just want to mention, is you could do the same thing as with a player with like an overlap circle. And that's totally valid. But I want to demo how a Raycast works, so we're going to do that. And for those of you who don't know, what a Raycast is essentially like an invisible line that goes from a point and has a direction. And then it extends in that direction for like a quote-unquote infinite length. And in Unity, what your Raycast does is it'll return the first object it hits, right? So we're going to say Raycast2D hit equals physics2d.raycast. And then we have to do the origin position, so we'll do our position, just for fun. The direction, which will be up, because we're checking if something lands on our head, right? So we want to look up above us where our head is and see if anything's over there. And then we can also, I said the ray was infinite, but we can also supply a maximum distance. And we're going to do that. We're going to make the maximum distance like 0.7. And that way, the player has to kind of actually be right on top of our head for that to work. And I think that should do it. So for now, we're just going to debug our actual Raycast hit. Yeah, sorry. This should be Raycast hit 2D. All right, so now oh yeah, okay, this doesn't give us anything useful. It just tells us the Raycast. So we're gonna do hit dots transform. So what that is, this is the transform of whatever it is we hit. So if we hit nothing, the transform will be null. Whereas if we hit something, it'll be the transform of whatever we hit with the Raycast. So right now, okay, so it's hitting itself again. And that's a problem because we don't want the enemy to hit itself and just immediately die. So we could use layer masks again, which would be a pretty valid solution. And actually, I think that's the one I'm going to do because that's probably the easiest. So we're going to say layer mask. We'll call it jump mask. And for a layer mask, we just pass it in here. And essentially, we're just going to make this to hit everything except the enemy now. Or actually, even better, we could make it only hit the player. That's probably a better thing to do, because then if like something else is above the enemy, they won't die. So we'll just set the jump mask to the player. And now, as you can see, the Raycast is returning null. When we jump over it, it's still null. But when we land on it, it's now the player, because we're on top of the enemy. Which is perfect. That is exactly what we want. So now, basically, since this will only detect players, we can just say if we hit something, die. That's it. That's all we have to do. So for dying, we're going to make this pretty simple, and we're going to say destroy game object. And what destroy does is it literally just destroys the game object, gets rid of it. So if we come back in here, now when we run this, the enemy's following us around, right? He's going to try to push us off, but if we jump on his head, he's gone. He just disappeared. He's gone forever. Into the void. So that is enemies dying. That's done. But what if we want to do something when the enemies die? Like right now we're just destroying them. What if we want to do something else? So we'll go here and we'll say void on destroy. And if you remember, this is called right before the object is actually destroyed. And we can do stuff in here. Now, more specifically, what I want to do is invoke an event. If you don't know what an event is, it's basically it's like a function. No, it's not a function. It's an object, and it has a list of functions, right? And you can add whatever functions to it you want, and then when you want to, you can invoke that event, and it calls all of those functions. And it's really good for decoupling your code, which is important to keep things manageable and things like that. So what we're going to do is we're going to create a public Unity event on die. And I think that should be okay. No, it's not. So to use events, we have to say using Unity engine.events, and that'll import the events namespace. And then in here, we're just going to say onDie.invoke. Now, why are we doing this? How is this useful, right? It doesn't actually do anything. Like if we run the game, it doesn't change anything at all. You know, it changes nothing. So why are we doing this? Well, if we go down here, we have all of these. Well, we have this list now, and we can add something to the list, and we can add whatever function we want, right? We're not going to add any functions right now, though, but you can imagine, like, if you wanted to play a sound effect, or you wanted to, if you had a scoreboard and you wanted to increase the score, you could do that through here, like every time an enemy dies. But what we're going to do instead, to prevent ourselves from running out of enemies, we're going to create an enemy spawner that will spawn a new enemy every time the current enemy dies. So we're going to go to this enemy spawner, and we're going to create a script for that. And I think we're kind of on to the next part of the slides. Yeah, events and coroutines, which we'll get to next. So we're going to create a script here, call it enemy spawner, and we're going to throw that on the enemy spawner. Hello, Mr. Computer. There we go. Enemy spawner. There we go. So we're going to open this up, and all we want to do is not a whole lot. So the first thing we're going to say is public, we'll say game object, enemy prefab. So what this is going to be is we're going to set it to a prefab of the enemy, and that way we can spawn a bunch of enemies at runtime. Then in start, well, actually we're not going to do anything in start yet. Then we're going to say public void on enemy die, instantiate enemy prefab, and let's say transform.position quaternion.identity. So I think we went through instantiate in the intro to Unity session as well, but I'll briefly go over it again. So what this does is it takes an object, which in this case is the enemy prefab, a position, and a rotation. So the position is where you want to spawn the object, and the rotation is what rotation you want the object to be spawned with. We're just using quaternion.identity, which means no rotation, because we don't want any special rotation. And effectively what this will do is create a clone of the object you pass in here at the specified position and rotation. So what we're doing is whenever someone calls this function, we're spawning a new enemy. That's all that sums up to in simpler terms. I could switch back to Unity. There we go. So we're going to take this enemy spawner, and we're going to move it up a bit, because right now it's like spawning enemies at its current position, so I want to move it up and out of the way. Then we're going to take this enemy, we're going to say on die, we're going to take the enemy spawner, and we're going to call on enemy die. And we better set the enemy prefab so we can actually spawn a new enemy. Which actually, we should create a prefab of the enemy. So we're going to create a folder, we're going to call it prefabs, open it up, and we'll drag and drop the enemy in there. So now if we go to enemy spawner, want this to be the enemy prefab, and we're good to go. So now if we hit play, we have this guy following us around, and if we jump on top of him, he dies and another one spawns. But now this is where something weird's going to happen. Why is there no new enemy? Right? Shouldn't that event have been called? Well, let's try this again. We're going to take a bit of a closer look. So we know the first enemy works, right? We did that before. We jump on him. Sure enough, it works again, so it wasn't a fluke. But let's see what's going on here. Like, why doesn't this guy spawn a new enemy when he dies? Well, if we look on here, there's no event. It's not actually hooked up. Why is that? So if we go to the enemy prefab, there's also no event here. And the reason for that is because this prefab has no idea what scene it's going to be in when it gets instantiated, right? So we can't just like reference this enemy spawner, because that only exists in this scene. If the enemy was spawned in a different scene, the enemy spawner wouldn't be there and it would be a whole disaster. So we can't just have a reference to it in here. So what we're going to do is we're going to delete this to start out. And then, in our enemy spawner, when we instantiate this enemy prefab, we're going to say GameObjectEnemy equals instantiate, because instantiate returns whatever you're instantiating. And we're going to say enemy.getComponent enemy. No, we called it enemy controller. And we're going to take the on die event, and we're going to add listener on enemy die. Okay, so this is kind of big and complicated. Like, what does this mean? What it means is, so we take the enemy from the instantiate function, which is the new enemy we just spawned. We're going to get the enemy controller component from it. Then we're going to get the on die event, and we're going to add a listener. All that means is we're adding a function, and we're going to add the on enemy die function. So the important thing is here, you don't do brackets. You're not calling the function. You're just referencing like the name. So we add that listener, and now, if this loads, thank you. So first we're going to have to add a new reference because we removed it from the prefab and it got all confused. So we're going to add an on enemy die reference for the enemy in our scene. But as you can see here on the prefab, there's still no reference. And now if we hit play, this should work how we want it to. That enemy comes, we jump on his head, a new enemy spawns. And this enemy, we jump on his head and a new one spawns. And then we jump on his head and a new one spawns. And this is because we're actually adding the event listener, right, in the script. And now we actually have a reference to it. Like, if before I kill that guy, if we pause and look at this guy. Oh yeah, so they don't show up in the inspector, but take my word for it, the reference is there. It's referencing the enemy spawner, and it's calling on enemy die, which is why new enemies are spawning. And that's sort of what events are for. That was overall pretty easy. Like, that's what? 2 lines of code here, and quite literally 1 line of code here to make like a pretty complicated enemy spawner work. And that's why we want to use events. That's mainly what they're for. So now the last thing we're going to do before moving on to the next section is we're going to delete the enemy from the scene because we don't need them anymore. And we're going to hop over to the enemy spawner. And in start, we're going to essentially do the same thing here. So we're going to move this into another function. We're just going to do it like that. So now this is going to function exactly the same as before. Oh, geez, I got to hurry up. I'm going for an hour already. But yeah, this will work exactly the same as before. As you can see, enemies just spawn, more enemies spawn. It's just this time we're spawning an enemy in start instead of having one in the scene already. So the next thing I want to go over is coroutines. So this is a way you can do... what's the word? You can sort of do parallelism. Not parallelism. Someone pinging me? Is that important? No. You can do... Well, you can do coroutines. That means you can do different things at the same time. Because the way things run normally, right, is like this happens, and then this happens, right? Everything happens in order. You might want something to happen at the same time as something else, or repeatedly, or something like that, right? So what we're gonna do is we're gonna do a little bit of coroutines here. So the way you make a coroutine is you make a function that returns an IEnumerator, and we're gonna call this spawn routine. It's good practice to end the name with like routine or coroutine so that you kind of know what the function is supposed to do. But that's not required. You can name it like any valid function name. But we're going to call it spawn routine. And all we're going to do here is we're going to spawn an enemy. Or, sorry. We're going to say while enabled. Yield return new. Wait for seconds. And let's say like 3. And then spawn enemy. So what does this do? Well, while the script is enabled, which if you remember, enabled was that little thing we could set to false to make certain things not happen. We're going to yield a wait for seconds. And what that means is we're just telling Unity, for this coroutine, we're going to wait for 3 seconds. And then we're going to spawn an enemy. And then since this is a while loop, we're just going to come back around to here, and we're going to start this again. Right? That's pretty simple. So all this is going to do is spawn an enemy every 3 seconds. But if we run this, nothing's going to happen because we never started the coroutine. But starting a coroutine is surprisingly easy. You just say start coroutine. And now what happens is Unity will take this spawn routine, and in the background it will wait 3 seconds and then run this, and then wait 3 seconds and then run this over and over and over forever. Or not forever, until this script is no longer enabled. So let's try this. Let's see how this works. So we have our enemy spawner. That should be all good. Oh, there's an error. Oh yeah, I just forgot the F. Okay, there we go. Sorry, what I meant by that is for decimals you have to add an F after them. Otherwise they're technically a double, and you want them to be a float. F just stands for float. Alright, so if we run this, now we wait 3 seconds, an enemy spawns. And in 3 more seconds, another enemy spawns. And in another 3 seconds, another enemy spawns. And another one, and so on and so forth. And then we also still have it that if we jump on an enemy's head, another one spawns. So basically what's going to happen is we're going to get a ton of enemies on here, and they'll eventually push me off. Which, you know, that's pretty fun. It's like, see how long you can survive. But yeah, that's that done. So just one last thing on coroutines. these are really great for doing really simple timers. Like, this is literally just one line of code to do a timer and wait for a certain amount of time. That's really simple. They're also good for a lot of other things. Like, you can look up the Unity documentation. I'll show you here. Unity coroutine. Look up Unity coroutines. In the Unity manual and scripting API, there's tons and tons of info on what you can return from these and what things you can wait for. Another one that I find specifically very useful, oh, that's not what I wanted, is you can say like yield return new wait until, and then like add an expression in there, and this will just wait until whatever that expression is returns true, which is like really handy for some stuff. But we're not going to get into that now because I am sort of running overtime here. But yeah, that's the spawning of enemies. Are there any questions so far? Okay, no one's typing, so I'm gonna assume no. I guess that means I'm a good explainer. But yeah, that's it. We're done. I hope you all enjoyed that. If there are any last questions before we wrap this up, I would be happy to answer them. But otherwise, you're all free to go.
Winning.
Oh, yeah.
Yes, and do we have the link and resources to the... Well, you're going to post this project, right, that you did here live?
The link to the repository is already in the chat. I'm gonna upload it, or I'm gonna actually like commit the project in a few minutes here.
Sounds good.
Yeah, here, I'll stop streaming, and I'll stop the Twitch stream as well.